Hello. Hello, everyone. As mentioned, hello, dobar dan, dobrý den, guten Morgen, guten Tag. Yeah. Anyway, my name is Armin, and I work for a company called solarisBank. We are based in Berlin, and we are a tech startup with a banking license. But enough about that. Today, I would like to talk about a few concepts I have discovered in the recent few years while working on building resilient applications. These concepts have actually changed the way how I look at the code these days. And before I step into this journey, I would like to just demonstrate how we usually do things. So, this is a simplified representation of something that is called N-tier architecture, very simplified, and it's usually represented as 3-tier architecture. We also kind of call it these days a monolith sometimes. So essentially, when a client comes to your applications and submits a request, like schedule a meeting, the application receives this request, validates the payload, does some business processing, and then persists the results. Application usually then also performs another query on your persistence layer and responds with the updated state. Usually, the only thing that's updated in this state is just the identifier the database gave to your record. And in the end, you get a response. And this is, I think, how most of us are writing, how most of Ruby engineers are writing applications. Is there anyone here who is not familiar with this concept? Okay, that's good. But sometimes, and in some cases, there are ways to do it differently, and there are reasons to do it differently. Sometimes you work on a business domain that is a very complicated one. Sometimes your code goes out of proportions. And sometimes you just want to do some time traveling and have fun with software with superpowers. So how can we approach and optimize our software to do things differently? Well, one of the first things someone may notice in software that there is a huge read-write disparity. Usually, applications have much more reads than writes. Sometimes it can be the opposite, but that's the case. So let's imagine how can we change this. So imagine that you have a new request on your API or whatever your interface is, and you ask your software to schedule a meeting, and you immediately get some sort of identifier. Your request is validated, just to make sure that everything is okay. And then you tell your client to go away. You have your ID, and you probably don't want to read about it, because you know what you sent me. And sometime later, or immediately even, your client might come and say, okay, I have interest in this meeting with this identifier. Can you give me more information about it? And yeah, why not? You get your information back. So we have essentially split our commands or mutation requests, or however you want to call them, from our query requests or request queries. And this might seem a bit complication, but this helps a lot. Because if we remove the extra stuff, you see that the way our application is functioning has changed. This is actually coming from a concept called CQS. It was devised by Bertrand Meyer and explained in his book 30 years ago. And it's one of the ways, one of the principles of object-oriented programming. But he has explained the concept on a level of your code, not on a level of a system. However, sometime later, this guy, Greg Young, came out and thought about it and said, oh, why don't we apply this on a whole system? It could produce some interesting results. And this concept is called CQRS. Essentially, with what was just described, this is the essential implementation of CQRS, is separating your write and read sides. If we take it a bit further and implement a separation of our systems now, then we can have two completely isolated systems working, one with writes, one with reads, which essentially enables you to scale indefinitely on either side by deploying just more instances of your software. Sorry, I have to take some water. And with this, we have unlocked our first superpower. It's called the Ruffle scale, and it's not a big superpower, but yeah. Essentially, what is in fact a current state? This is the question, and we as the software developers have been working with this for such a long time that we actually sometimes forget to ask. Because every time we change the record in a typical CRUD application, what happens is that we are forgetting data. I'm not going to say destroying information, because other than black holes, this is impossible, but we are forgetting what we knew before about our data. And this information can be useful, and often is. Current state is something that we perceive. It's not something that actually exists in the real world. But let's move on. We are a bit limited at time. The second concept I want to mention is also called eventual consistency. And now, this is a thing that you will encounter as soon as you start building distributed systems. I don't know how many of you are. Good? 1, 2. Essentially, eventual consistency means that you can no longer rely that your data or your state is transactional, and it's immediately going to change the way you want, which is fine. We just think it's not. Because most times, as I've shown, the client that's writing the data doesn't necessarily need to immediately check, is this data written? He already knows he got the confirmation, or she got the confirmation, data is there, go away, and he or she can come later, or actually, usually it's some other reader that reads the information and check something. So it's fine that we have a delay of 1 second, or 10 seconds, or 10 minutes. For instance, in Germany, where I work, we have this system called Elster. So it's used to submit your taxes every year, which reminds me I should do it. But what happens is you go to a website, you create an application, submit your username, password, etc. And they say, everything's fine, go away, we'll send you a letter via post with your credentials. And this letter arrives several days later. Cool, now I can log in and submit my taxes. And this is eventually a consistent system, and it works. And if you take a look, most businesses work this way, because if you go to your barista and ask for coffee, it's not going to magically appear in your hand. There's a process, so he needs to go somewhere, and while he's doing this, you can go away, walk around, look at the pictures, etc. So that's fine. I mean, I wanted to tell a story about how Dana, our fellow speaker, got problems with the airports, but that was, I couldn't just compose it into this very well, so sorry. Anyway, now that we have separated our system in multiple self-contained parts, we can do weird stuff. But what is actually this So yeah, I forgot one part because I lost my speaker notes, so I'm just speaking out of my head. There is a meeting scheduled and meeting cancelled events that have happened. So what is actually a current state is just a projection of events that have happened in the past. If you take a look at how the databases work in the background, there is something called the transaction log, in some cases called journal log. And if the database crashes at any point in time and boots up again, it can recover easily because it can read the log and reconstitute the state as it was. And if we start looking at the state from this point of view, we can see that we can put everything that has happened, instead of mutating the state, we can just put it in a series of events. These events can then be replayed and can recreate what we know as current state. Just a second, we have the pointer. And if we by any chance happen to lose this current state, I read an article on Reddit where this guy came to work on his first day, he dropped the production database. So, I mean, it's not his fault. If you have access to this from your testing environment, you should be expecting this to happen. But in this case, and I don't want to draw any further parallels, you can essentially destroy any of these projections that are viewed as a current state at any time and just rebuild them from scratch. It sometimes takes time if you have a lot of records, but it's fine. As long as you can reconstitute your data at any point, it's not something to be concerned about. Good thing also is you can rebuild your state in any medium you want. So, let's say this is a relationship database. Let's say we built a state completely in memory for this projection. Because this is a process that requires fast access. And we use some sort of a GraphQL database here. It doesn't really matter which type of database you use in order to project your data. You just use whatever you want. And if it's no longer suitable to your needs, just wipe it, recreate it from scratch. It works. And this concept is called event sourcing. It was described also by Greg Young, and some smart people have written some really cool quotes about it and articles, as can be seen on the slide. And one of the things we unlock with this is time travel, what my talk is all about. And this is the only slide about it. So time's hard, but time can be easier if you can travel through time. Anyway, if you store your state as a series of events, and you want to look how your state was 1 year ago, you can do it. Because you can just replay events up to that point in time and see what the state looked back then. You haven't lost any information, which can prove very useful when debugging. Imagine that you have a capability to reproduce exact state of the system at the exact time that the bug has happened, and then replay an event after an event after an event until you hit where the bug has happened. This is super useful. Also, sometimes you want to change some ways how the software has worked and you want to explore stuff. How did this work a year ago? But moving on, there is another superpower that comes with this, and it's called precognition. Or to translate, it's the ability to foresee future needs of your software. So imagine a situation, let's say you work in e-commerce. Anyone here? Okay, no one, doesn't matter. Or in any other industry, and your manager one day comes to you and says, look, I would like to send a promotional mail to all of the users that we had that put this product in a cart, then took it out of the cart in the last year. And in a CRUD system, we would go, yeah, you know, systems don't really work like this, you know. We can do it in a couple of months for the next year. But with this, you can build features as if they were there from the first day, as long as they're about the data you are collecting. So with this, you just say, no problem. I'm going to build you a projection of all of the users that have put the event, that have created events, which describe this state that you want to explore. And just build a complete record of this. One of the other superpowers is total self-reconstruction. I already talked about it. This is the ability to just wipe your data, wipe your state, reconstruct it any way you want. So I will not keep on this. And the last, but not the least, there is a superpower called Enhanced Charisma, and it gives you +5 versus the regulators. And this comes from, I work in a very regulated industry. I work in banking. So we are under constant scrutiny of regulators, and people want to know how do we do things. So if they come to your company and you're using a technique like this, they're gonna love you, because you essentially have immutable record of everything that has happened, and they can just inspect it as much as they want, and everything works really well. There are some other benefits as well. Debugging on the exact state via time travel, this was already mentioned. Testing without updating records or deleting records is really, really nice and way easier than doing the CRUD stuff. And backups on an event level are possible. You just create another projector, which will, or reactor, so these are how these things are called on the right side, which will, for every event, just push it somewhere else. So essentially, you can have real-time, event-by-event backup of your system. And, okay, this was me a couple of years back when I was told about this concept. It was like, why has no one told me about this before? This is such an amazing concept. It looks simple, but we can do so much with it. Why are people not teaching this in schools? So, I decided to go outside and speak about it. Maybe some of you have never heard about it before. Maybe some have. But actually question, who of you has heard about these concepts before? Well, nice, half a room. Who has used it? Way less. So, that's about it. But there are some problems. As everyone will say, this is software development, so trade-offs. The mind shift required for a software engineer, especially since we have been taught for 40 years to think in a different direction, is actually quite challenging. The second one is hiring or training engineers. This has not been an easy task. We are spending a lot of time training, which is fine. Hiring people who are familiar with the concept, good luck. And while eventual consistency is a nice thing, and it's not a bad word, when dealing with legacy systems or third-party systems, this can sometimes be challenging if the third-party systems are not idempotent, which they rarely are. But in practice, there are some cheats. So, projectors and reactors, so these are the things that project data into state, into what is considered a current state, they should be idempotent. And you should strive always to make them like that. The second one is, if you are storing your events, please use aggregate scoped sequence number. You can come to talk with me later to explain what this really means. But essentially, it's much easier to deal with concurrency and race conditions if you number your events in the way it happened. Otherwise, you might run into a bit of a weird race condition problems if you have multiple writers to your state, which you also shouldn't if you can avoid it. Yeah, and we can reuse when we aggregate the state, when we build the entities, because on the command side, entities are never taken from projections. They're always rebuilt from events whenever written. So once you build this thing, which is representation of your current state prior to sourcing a new event, you should always do this and never use projection, because projections are eventually consistent and cannot be trusted. In some cases, you can use this entity that you built or an aggregate and respond with its state if your client really expects some response. If you're on a green field, you should just say 202, go away, this is your ID. And if you have something like a domain transfer object, which is used in order to translate data between your framework or whatever you're using into your business logic, using this identifier can be good for deduplication of the events, because in distributed systems you can get duplicate events. So putting a constraint on this and mapping commands to events one-to-one can help. And if you have synchronization errors or working with the legacy systems, there's a pattern called Saga, which helps a lot in dealing with these and also managing your state. Anyway, I know it was a bit confusing. Sorry, I lost my speaker notes. But thank you very much. And as I mentioned, I work for solarisBank. We are hiring. You can talk with me about it. And feel free to come and chat with me about this concept. And I'll be happy to explain it in more detail. Thank you.
Thank you very much, Armin.